Yes, good evening and welcome in this session. We are going to discuss today modified Euler's method. Okay, and this is one of the fastest method. So, what we are going to discuss today, this is very important before starting the session. So, Euler's, the difference between Euler's and modified, improved Euler method or modified Euler method, also known as Heun's method. Okay, so Heun's method, also known as the improved Euler method, is numerical technique used to approximate the solutions of ordinary differential equations. It's an advancement over the basic Euler method and belongs to the family of Rankata methods. This is one of the type as we will discuss about the Rankata methods in the coming session. Okay, and Eon's method improves accuracy by taking a weighted average of two slopes. In the case of Euler, we will consider only one slope, but in this case, the improved Euler method based on the slope, average slope of the initial point and the final point in the interval. Okay, and if we compare with the Euler method, Euler's method is a basic numerical technique for solving ODE where the derivative at a point is approximated by a straight line. It's a straightforward and to implement, but can have very poor accuracy, especially for the stiff ODE or the equations which make in very frequently changes in its graph. Okay, and when using large step, this type of problems are not accurate. But in the case of Eon's method, improve upon Euler's method by considering the slope at both the beginning and the end point of the interval, resulting in a more accurate approximation. So, before starting, I would like to share my screen, and the entire content which we will discuss will be provided you, and along with the as you know, yesterday we discussed this method, Euler method, before first we prove the result. But today I will provide you one book in which the proof of all these results are given, which we are using, but some specific changes are required for computing implementation. Okay, we need all these results in the generalized form as we discussed yesterday, and today also we will do in the same way. So first, I would like to share my screen. Please let me know I am perfect audible to all of you.
Yes, sir.
Okay, thank you. So this is my entire screen, and in this entire screen you will see this file, and this is the PPT along with my MATLAB. So all the things are very clear to all of you. Yes. So first at this place we will go through about the modified Euler's method. Okay. And you can see in this diagram I have two pages I have opened, and this book will be shared with you, so that if one need to require to prove the result, then you can easily go through the. Okay, so yesterday what we had done, we have the same diagram, and on the basis of this diagram, which is 10.1, and the page number is from this book which I am following. The page number is 430. Okay, so this is the page number 430, and I will not go through the proof of this result because yesterday we have already discussed. Yes, come at this place. This equation is important for today's session. Okay, yesterday we used this equation. Okay, now come here. This is the modified Euler's method. Okay, which we are going to discuss today. So first we need to find out the slope at the point P, and this is the f x naught y naught, which is the slope at the point P, and by using the same Euler method, we have this value y1 at the point at its place. Where is the diagram? Yes, this is the diagram. Okay, so at this place, at this point, we have this is y1. Okay. So now in this method, what is there? We will calculate at the point P1, which is x1 and y1. We will calculate the slope at this point also. And you can see this is x1 and this is y1, dy upon dx. This is the slope of at the point P1. Okay. And in this method, when you will go through, you will find that this method is based on the slope, average slope at P and P1. Okay, so this is the slope at the point P and this is slope at the point P1, and this is the average of the slope. Okay, and we have y naught. This is new value, and this value will be modified until we have a better result corresponding to the same. This new value we will calculate again in the next step. You can see this is y1. This is the new value. Okay, and at the same point, this is x1, but this is modified value. Okay, so this we will repeat until two consecutive values of y are agree. Okay, this new value will be used to get the next point. Okay, so ultimately we have these two equations. This is y2 and this is modified y2. Okay, so we need the generalized form of this modified Euler method, and that I have introduced in this presentation. Sorry, this is control and L. Okay, so you can see this is the same equations which we discussed there, equation number 1.2 and 1.3. The difference that these are the generalized form. In the first equation number 1.2, you can see yn plus 1 is equal to yn plus h f tn yn. This equation is based on the first slope of the interval. And in the equation number 1.3, you can see we have the slope at the point tn, yn, and the slope at the point tn plus 1 and yn plus 1, and their average. Okay, so this is the new modified value yn plus 1 is equal to. So these two equations are required in a generalized form to write MATLAB programming. Okay, and once you will be able to write MATLAB programming by using these two equations, and you can, the most important thing is you can easily generalize these expressions by following the proof of this result and this result. Similarly, you can get the values of y3, then y4, and then you can generalize for yn. And ultimately, we have these two equations, 1.2 and 1.3. And each time you need equation number 1.2, first we will use Euler method, then we will modify it. Okay, and this method is known as Heun's method, or you can say improved Euler method. And also along with we will apply analytical method. So what we are doing in the session, we will first we will write the program for this improved Euler method. Then we will get the result. Also, we will use Euler method, their programming, and also we will get the solution analytically. Just we will use analytical solution. Okay, then we will compare all these three results, and then you will realize that this improved Euler method is more accurate as compared to Euler method. Okay, so let's discuss now the MATLAB programming. Come here, I have the example number 1 first. Okay, so this is we have numerical method 2, which we are going to discuss. First, we will take the first example. Okay, and I have to close all these files. Yes, so this is the numerical result, and in this numerical result, we are choosing this example y dash is equal to minus 2ty and y naught is equal to 1. This initial condition we are given, and we want to get the value when t is equal to 2. Okay, so this is our problem, and to solve this problem, we have to write improved Euler method. Okay, and then we will implement in this. So what do we do? What do we do? What here you can find. Here is the complete programming of the same. Okay, so along with the yes, this is the another file. In this file, just we write the differential equation. Okay, which is y dash is equal to minus 2ty. This example we choose to simplify. Just 1 minute. What I have taken as space. Yes. So this is the equation y dash minus 2ty. Okay. So first we are writing the function for this differential equation y dash or dy upon dt. Dy upon dt is equal, both have same meaning. So y dash for the function for this differential equation we have is this one. This is the differential equation, and we create a user defined function for this ODE, and we save with the name this one. You can choose any name depend upon your choice. Okay, now come to our improved method. Okay, so in the improved method, what we need ODE, differential equation. Okay, we create in the form of a function for improved Euler method, but we with the name of Heun's method. Okay, so we create the function for this one, and the file name will be saved with this name, and you can find in the at this place also. So this name and this must be same. When you will create the script file, don't change this name. This the file name must be this one. Okay, .m file. So these are the argument we need to pass through this method. Differential equation t span, the interval for t, and this is the initial condition, and the step size which we need. Okay, so these are the arguments which we need. Now uh, t span. For the t span, this is the initial value. Okay, and this is the last value, and this is the step size. Okay, come to add space. So t span is equal to this one, the interval. This is the first value. Okay, you can see at space, and this is the last value. Okay, Gangtak, we discuss after the complete discuss of this entire program. If you have any question, we will discuss. Okay, so first let me to explain everything which is required for this program. So first we need to create a vector for t. Okay, this is the input value. This is independent variable. Okay, and y depends upon t. Okay, so this is the initial value and this is the last value. Okay, and on the basis of h, the step size which we choose, according to that we have a t vector. This is time vector. Okay, and the number of points which are in this t vector, the y vector also must have same. The length of t values and y values must be equal. Okay, otherwise we are not able to plot the graph. So that's why the length of the size or the length of these two vectors must be same. So what we do for the same, we are using at this place zeros. So zeros vector will be generated, and the zero vector have the length or the point according to the size of this t value. So whatever we have the initial value, what will be the last value, and the value of step size according to that, this vector will be generated. Okay, suppose this vector has 100 points according to the values of initial value and last value and corresponding to h. Then what this vector this will do, this is the size. Okay, this is the size of t values which will be computed at this place and store at this place, and this value will pass in the size function, and we will have the same length as at this place. So zero vector will be generated with the same length as we have t values. So ultimately what we have the length of this t value and that of y values will be equal. Number one. Now after we need the known values. Okay, so this is the known value which is y naught, whatever we have the initial value, and that will be automatically stored in first index of y. Okay, so what is the meaning of y value 1? This is the first index of the zero vector. Okay, and the first element of this zero vector must be y naught. So we are initializing the indexing of all the element of this y values. Okay, so this is the first index. So first value which we are given must be used. Now come here in this for loop. Okay, so before discussing the for loop, we are discussing the method. Okay, this is our method. You can check here. See, what is K1? K1 is slope at the point P. This is the first slope of the interval. Okay, and K2. K2 is the slope at the point P2. P1, sorry. We have 2 points. One is P and other is P1. So this is the first slope of the interval. Okay, the entire interval is divided into the very small step size, and ultimately we have very small intervals. Okay, and when you will have I is equal to 1, when you will have I is equal to 1, this will be T1, and this will be Y1, and this will be T2 and Y2. Okay, but here the meaning of T1 and T2 is index. Okay. T1 means T naught. Okay. And Y1 means Y naught. As you can see, the value of Y1 is equal to Y naught. So these are the index. Note these points carefully. Okay. So this is the slope at the point P1, and this is the this is the slope at the point P, and this is the slope at the point P1. And what is at this place? This is the slope, average slope of P and P1. Okay, and when you will add this slope in yi, then you will have yi plus 1. Okay, in the place of n we are using I. See once again this formula. See at this place. Okay, see in this place. Just 1 minute. I am taking Epic pen. Okay, my Epic pen will open. No, where is my Epic pen? Okay, now it is fine. Yes, see. So this is the first slope, and this is the slope at the point C, like in this way. These are the points. Okay, this is the point Tn, and this is the point Tn plus 1. So the slope at the point is this one, and the slope at corresponding to this point we have is this, and this is the average. Okay, so this we denote with the K1, and this is K2. These are K1 and K2. Okay, and at the place of n, we are using at the place of n, we are using I. Okay, so this becomes yi plus 1 is equal to yi and ti plus 1 and yi plus 1. Now come back in the MATLAB. Come back in the MATLAB. See here. Okay, so this is yi plus 1. This is I plus 1 is equal to yi, and then we have average of K1 and K2. You can check it very carefully, and you can easily compare. So the K1 and K2 are computed at this place. Okay, now we want to initialize with the given value, and for that we have to apply for loop. See here, this is the for loop, and we are going to implement from I is equal to 1 to length of t values minus 1. Okay, I have one question for you. Why we are taking at this place minus 1? Anyone please? why we are taking at its place -1? Anyone, please? This is important. Other things are very quite simple. See, we have see at
Because
the
it should
page.
not go out of the interval.
Yes, yes. Thank you. Thank you. This is T naught and this is Tn, and here is Tn -1. Okay. So when you will pass this value, you will have the last value is this one. Okay. Tn, the value corresponding to Tn will depend upon this value. Okay. So that's why the last value we have is corresponding to Tn. That's why we are using length T value -1. Okay, when this will be generated vector, we will have the total number of points, and the last value, this value will be on the previous one. That's why we have to reduce -1. As you know, the formula yn plus 1 will be equal to yn and so on. So this value is required to get this value, or yn will be equal to yn -1. Okay, and something. So up to this value, we need yn. We will get the value corresponding to yn, or the value of yn. Okay. So now we are initializing all these values. Ti will pass through at this place. Okay. This all the values of Ti, all the values of T which are stored at this place corresponding to this interval will be stored at this place, and corresponding to index, all these value will pass at this place as well as at this place. So all the values will be which will be updated, the y value will be at this place will be updated, and corresponding to all these, when you will run the program, you will have the all the values of two vectors. Okay. And the function, how we can implement now. This is the differential equation. This is the required our method which we want to implement to compute the differential equation. Okay. So now this is the t-span. We want to get the value in this interval. So the initial value is 0 and this is the final value. Okay. And y naught will be equal to 1 according to given condition. This is the given condition. Okay. And the step size which we are choosing at space 0.1, we can modify. We can choose any step size 0.1 or 0.05, whatever we need. Okay. Now we will call Heun's method to solve ODE. So this is the function, and the function which we create at this place. Okay, this name. And now we will pass all the argument. This is the differential equation, and the t-span is this interval. Okay. Initial and final value you can see, and y naught, the value of y when we have t is equal to 0, and the step size. So corresponding to all these argument, we have assigned the values. After that, so when you will run this program, all the values of uh, y corresponding to t will be stored in this argument, this assignment. Okay. After that, we want to plot. For the plot, we will use the plot function, and that is very quite simple. Uh, this is the t value, then we have the y value, and you can assign at this place marker. You can fix the line width, which is 1.5, x label, y label, title, grid on, and if you need numerical result, okay, then you will use this statement. We are using at this place t values transpose. Okay, otherwise this will be row vector, but we need in the column. So that's why we are taking transpose at this place, and same for the y vector. Okay, and we are displaying the result at this place. And along with you can enter at this place CLC and clear, then close. Okay. So now when you will execute, you have this solution, and all the things are very clear, I hope. Okay. So this is the graphical, as well as you can find the numerical value in the command window. So these are the numerical values also. Okay. And all these values store in Z argument. When you will double click on it, and you can check this is the x vector, this is the y vector, this is the t vector, this is the y vector. Okay, so both the values are available in this argument. So this is the complete process to implement MATLAB to find out the numerical solution by using improved or modified Euler method. Okay. Now, yes, please. If anyone have question, someone raise hand. Now you can unmute your mic.
Hello, sir.
Yeah, Gangtak Nanpan, you have question?
Yes, sir.
Yeah, please.
Why is it that, what is the meaning of that T-span?
T-span. Okay. See, T-span is the interval for T only, nothing.
Okay, interval of T.
Yes, yes, yes. You can see once again. Yeah, C at space. Okay,
Okay,
this is the first value and this is the last value. Okay, this
okay.
is T span and entire everything which we need in the numerical method. I tried to explain in the sked file and corresponding to all these I comment. So all the statements which you can see in the green color, all these are the explanation corresponding to each statement. So this will help you to understand all these statements.
Okay, sir,
Any more question?
yes, sir, can we
Uh,
say T-span is the same thing as time, the range of time involved?
Pardon?
Can we say T-span is the same thing as time range or time interval? Am I
Time
right?
interval. See, when you will solve this differential equation, we have some function of t. Okay, y is some function of t, and this will generate some type of a function. This will be some type of graph. Okay, so at this point, you will have the value which you are given when t is equal to uh, 0. Then the value of y is 1. Okay, so what is the value when you have t is equal to 2 and we want to
Two.
compute the value of y? Okay, so in this interval, we want to compute all the values and this will be stepwise. So we will go in this way. We will divide this interval in very small step sizes. So on the basis of this point, we will get this value, then next value. Okay, so this is T note. At this place we have T note, and T1 will be equal to T note plus H. T2 will be equal to, we have T note plus 2H, and so on. Okay, so for the more detail, I think you did not attend very first yesterday lecture. That was very important, and everything, all this which we need has been discussed yesterday. So you can get more information through the book also. But we first you need to understand the method. Okay, Euler method, then modified or improved method. What are these? Then how you will calculate manually yourself.
It's okay, sir.
Okay, what are the procedure? Only then you will be able to implement in the MATLAB. Otherwise, it
I'm
will be
okay
very
now, sir.
hard. Yes, please.
I'm okay, sir.
Okay.
So I saw in your program, in the code you wrote I underscore, sorry, Y underscore I. So the question that came into me was that, okay, what is the difference between Y open function of I, that is, and Y underscore I? What is the difference in that code?
I don't get your question. Can you please repeat?
In the code you displayed,
The
there is a
code, just
place
1 minute. I'm sharing my screen and just
where,
1 minute. Okay, and I have this file and this is the code. Yes, please.
yeah, Y underscore I.
I is used for index. See at the space. See if we have this is the interval. Okay, this is T naught and this is the final value Tn. This is the first point and this is the last point, and you divide in sub intervals. Okay, so by dividing this one, these are the T values. Okay, this is the this value t span. This is the t naught. Okay, and what is this t span 2? This is the last value. And what is h? H is difference between each sub intervals. So the length of each one is same. All these are equal length. Okay, so when according to this one, the number of points will be generated in this interval from t0 to tn depend upon the value of h. If the value of small will be, then the number of points will be large. If you will take a large step, then the number of point will be less as compared to small size. Okay, so the number of point which will generated in this vector depend upon the size of the step. Okay, so all these point t1, then you have t2, and so on tn minus 1. So these point may be 100, 200, 500, depend upon the value of h. Okay, so the now thing is, what is I? I is index which we will use for these values. So when you will take at this place I is equal to 1. Okay, I is equal to 1 means T1. T1 is equal to T naught. Okay, when you will have T2, this loop will vary from 1, 2, 3 up to n minus 1. Okay, we need this last value because this value depend upon the first one. That's why that's why we need up to this one. So T2 will be equal to the next T1. Okay, and so on. So this I is only index for all these values which you will get the point at this place. Okay, now in the same way, we have the another way, another array which is y values. Okay, we need to compute the y values corresponding to each these index. So corresponding to this one, we have y1, and the value of y1 is y naught. Okay, so when you will have I is equal to 1, then this value will be computed, initialized from this place. Okay, then when we have I is equal to 2, all these values will be computed at this place by using the method. Okay, so this is the new value. This is the C at the place when you will have I is equal to 1. When you will take I is equal to 1, what happened in these equations? See, T1 from this equation, T1 is equal to T values and index is 1. Okay, and what is about this one? This will be y1 is equal to y1. This is what is t1? T1 is equal to the first value which is 0, and y1 is equal to, you can see, this is y naught. Okay, so these values are computed and stored in these values, but at this place what will be there? When I is equal to 1, this will be T1, this will be Y1, and you have these values. K1 will be computed. Then when you will put I is equal to 1, this will be Ti plus H. Okay, this is the step size. So these are the next value. Next value is T2 and Y2. Okay, so these values will be computed. Okay, and the slope at K1 and K2 will be, we will take at this place average of the slope, and at this place we have Y1. Okay, and this will be the new modified value, which is Y1, and based on the improved method. Okay, because improved method depend upon the average. At this point, this is the point P and this is the point P1. The slope at this point and slope at this point and the average of these 2 points, these two slopes, we have this value. Okay, this is the improved method. But first you need to establish the result formula and understanding, then you can easily implement in the computing. Otherwise, if you are not able to understand, see once again, see at the place. So how this method is established? If you understand the derivation or the formula Yes. So the equation numbers, yes, at this place. Okay. So you need to establish these equations, how the equation was established. Okay. And what are the, if you will compute these values manually yourself, then what will be the procedure to get all these values? Here is the example. Okay, these are the mean values. Okay, this is the old value, and this is the new value. Okay, once you will solve this example, then after you can compute by using this method with the help of MATLAB. So this will build understanding about the method, how we are implementing to solve. And if you have more understanding, then this will be very simple to implement while computing by using MATLAB or other computer or other software like we you can use Python or C or C++, whatever. Okay, but the understanding of the method is more important. Only then you can write the program and you can implement. But also I expand that you need these two equations in the generalized form, equation number 1.2 and 1.3. Only then you will be able to write the program for this improved Euler method. Okay, once you are able to write the program and test it, verify it, then you can do several experiment on this. Is it okay?
Yes, sir.
Now, I have one more example at this place. Uh, See in this example number two, but I will provide the code. I will not discuss this example. We will discuss now only the comparison. We are going to discuss about the comparison, and this is the example. Okay, and sorry, this file. Okay, and analytical expressions. See here. Okay, this one and example ODE. We define at a space. Here is the method, and this is the analytical. Okay, see at a space. What we have done at a space, we are using three method. One is analytical, second is Euler method, and third is modified Euler method or Heun method. Okay, so by using the same, we will compare these solutions and see the equation we have is this is differential equation ODE y dash is equal to minus 2y. I will put also at this place. Okay, so the differential equation we have is y dash is equal to minus 2ty. Okay, and also along with we are given the condition y0 is equal to we have 1. Okay, and then what y2. Okay, y2, yes. So this is the statement, and we want to compute the numerical values using Euler method, Heun method, and then we will compare with the analytical solutions. Okay, so what we do first, we will write this differential equation as a user defined function. Here is just only we have user defined function, and there are two argument t and y, and dy upon dt is equal to minus 2ty. Okay, this is one part, very simple. Now we have, yes, this is the Euler method. Okay, we create a function for Euler method, and this is the function f means dy upon dt. F means dy upon dt. Okay, and this is the initial condition, and this is the t span, the interval which is we have if we are given the value at t equal to 0, and why we want to get the value at t equal to 2. So we have the interval 0 to 2. We will start from 0 and get the value 2. So we have to divide the interval 0 to 2 in sub interval or in the number of points. That will depend upon the value of h. Okay. So here, sorry, this is the Euler method. Okay. Yeah. And then we have h, the step size. And this is the same statement as we use in the Heun method. Okay. And this is also the again same statement. And this is also these three statements are same as we use for Heun's method. Okay. Now we will apply our method. So, what is Euler method? Come back at this place, and this is the formula. Yn plus 1 is equal to yn plus h f t and yn. So this on the by using this formula, we can note this point very carefully. In the left hand side, we have yn plus 1, and right hand side we have yn plus h f t and yn. What is t f t and yn? This is slope. Okay, f t and yn is slope at the point t and yn. Okay, so using this equation 1.1, you can easily write this is yn. This is yn. At the place n, we are using I. Okay, this is h. This is h. Then this is t value. Okay, t and yn. Okay, so this is the right hand side and this is the left hand side. Now we want to compute all these values for the indexing, which will start for I equal to 1 to up to the this value, length of t value minus 1. Okay, so for that, this is the updated value or the corresponding to all these values. Okay, so just we will apply at a space for loop and end at a space, and this end is used for the function. So when you will save this file, the function will store in your dot file, which you can see at this place. And this is the same method which we discussed just now. Okay, no new in this method. The same code is here. Okay, and at this place, the analytical solution of the differential equation we have is exponential minus t square. Okay, so just we write at space the analytical solution is y is equal to e raised to power minus t square. Okay, so this is the function, and we save this function with the name of analytical solution of the differential equation. Okay, so we have here three functions. One is based on analytical, second is based on Euler method, and third is Heun's method. Okay, so these functions has been created and saved in the same directory. Now come to for numerical results. Okay, so this is the differential equation which we store at a space. You have now these four script files, and now at this space we will compute and we will compare all these results in the single graph. Okay, this will be very interesting. So now first we need the t-span. The value of h we are choosing at space 0.1, and the initial value is 1. Okay, so this is the Euler method, and we are passing the argument. This is the differential equation, this is y naught, this is t span, and this is h. And for the Heun's method, we have the also same argument. Okay, and for the analytical, okay, we need only the t this argument, which is t analytical, t span, first and last value, and argument at a space the step size is 0.01. Okay, and at a space the value for analytical expression will be stored in y. Now we will plot. When you will plot, see at this place, this is the plot for Euler method. This is plot for Heun's method or improved Euler method. Okay, this is plot for analytical solution. And then you know the importance of hold on and hold off. Okay, hold on is used for to combine all these graphs in the same. Okay, then we have X label, Y label, and legend, title. All these are the similar thing which we discuss in the 2D and 3D plotting. So when you will execute these sequence of statement and see, here is the graph. Here is the graph, and you can check from legends. So on the top, on the right hand side, you can see in blue color, the graph is for Euler method. Okay, which is you can see, and in the red color we have improved Euler method or Eon's method. Okay, and in the black color you can see analytical solution. But when you will compare all these results, you can see the difference between all these three graphs. So ions and analytical solution, approximately we have the exact value, and very small difference can be observed at this place from the value which are you can see the difference 1.4 to uh, 2. Okay, very small difference can be observed. But in the case of Euler method and the analytical expression, you can see the big difference. Okay. So in this way, you can compare the result, which method is more accurate, and and can provide more accurate result. Okay, and comparison is also there. Also, I will make some more change. I want to see some more changes. See at this place. Okay. For the analytical, we are choosing at this place 0.01. But for the numerical methods, we are using the step size 0.1. If I reduce this size 0 to 0.01, and again when I will run this code, see, yes, now it is very hard to compare these values. Okay, but if you will use this sign, just we are checking. Now you can realize, you will set the plus sign and you can check. There is some difference. So you have to magnify. Okay, at the right top you can see zoom in. So when you will press zoom in, and you uh, when you will magnify, you can see the difference. Okay, there is a very small difference. Okay, so but the Eon's method and analytical solutions are absolutely same. Okay, but still there may be some difference. So we have to compare the numerical values also, and this is all about how you can compare the result. And there will be some more uh, analytical study about these methods, which we will discuss in the coming sessions. Okay, so everything which we need for the numerical methods, analysis, okay, and errors, sensitivity, etc., what we need, everything we will include, but step by step. Okay, so I think this discussion is very helpful. If you have any question, please feel free to discuss with me. It may be, I think this lecture is helpful for you. If still there is any question or any gap to present, please feel free to discuss with me.
Excuse me, sir.
Imtiaz Ahmad, yes, please.
Yes, sir. What about these two methods towards the integral equations? Can we apply?
Pardon?
Could we apply these methods to find the numerical solution of integral equations?
Okay. There will be different method because all the methods have some specific implementation. But if you have integral differential equation, for that we have to find some other numerical approach. Okay. I'm not sure this will be because when you will apply in integral differential equation, then this method is not applicable. Okay, this method is applicable only for differential equations, not integral differential equation. If integral is involved, then we have to apply some different approach.
Thank you, sir. Thank you. And one thing, sir, you discussed the two methods, Euler and the improved Euler. What about their order of convergence, sir? Could we find that order of convergence in the program to numerical thing?
Okay, convergence. For the convergence, we will include in the coming sessions. But now just include only the computing part, numerical results. Okay, the convergence and the other part errors, etc. We will consider in the coming session. Keep continuity in listening the lectures, and in the coming sessions, we will introduce.
Thank you, sir. Thank you. Actually, sir, recently I did one paper on this, the numerical solution of functional interrogation applying the Euler method.
Applying the
Euler method. This you discussed the Euler method.
okay,
Yes, sir. Now,
but I am not
my
sure. But I am not sure this will be applicable or not. And if you have such problem, and if this will be applicable, we have to see. We have to see whether it is applicable or not. And if this will be applicable, then there will be some different approach we have to adopt. But
thank you, sir.
I'm not
Thank
sure. But I'm not sure whether it is applicable or not. But I
you. Okay,
think
sir. Thank
this
you.
is not. But I think this is not applicable. If you
Mm,
are doing in such way, I think there will be some along with it, there will be some more approach.
okay, sir. Thank you, sir. If I got need any help, sir, because I want to apply this method, integro functional differential equation,
Integral
then
differential equation. Yeah.
yes, sir. Yes, sir.
For the integral differential equation, we will check, but I'm not sure. Till now, I did not study the application of numerical method for integral differential equation. Yeah, but there are some different approach to solve this type of problem. But I did not check whether it is applicable or not. We can check it.
Okay, sir.
We can check it.
Okay, sir. If I'm working on this, sir, presently. If I need any help, sir, I can contact you. Thanks,
Always
sir.
most welcome. Always
Thank
most
you, sir.
welcome.
Thank you, sir.
Yeah.
Thank you, sir. Thank you,
Yes.
sir.
Yes.
Today's lecture was very interesting, sir.
If you are able to solve integral differential equation using this method, then we can implement MATLAB also.
Okay, sir. Thank you. Thank you,
Okay.
sir.
But the thing is that first we must have the understanding about solve the any type of differential equation using some specific methods, because there are numerous methods are there in numerical to solve uh, different type of problems. Okay. But
Sure, sir.
if we are able to solve by using some specific method any differential equation, then we can create the programming by using MATLAB, or we can use also the Python, we can use C or C++ also. Okay.
Thank you, sir. Thank you, sir.
Yeah.
Today's lecture was
Yes. Yes.
very interesting, sir. Very interesting. Very
So
interesting.
thank you. Thank you very much.
Please,
Any more question,
please, sir.
please? Any more
Please,
question?
please, sir. Please, sir. In upcoming, sir, lectures, please, sir, add up these order of convergence. How we
Yes,
can
yes. Actually, the thing is that when we discuss all these things, in 1 hours we are able to discuss only one thing. Okay. If we divide the problems, yesterday someone asking about the comparison. So in the very first lecture, how I can compare all the things? First, you
sure,
need
sir, sure,
have
sure, sir, sure, sir.
yeah, okay. So this is the sequence. So in the coming sessions, everything will be there, but
Thank you, sir. Thank
you
you.
also need some patience.
Sure, sir. Sure.
Okay,
Sorry.
wait,
Sorry.
wait everything. Yeah.
Okay,
Okay.
sir.
So
Thank you, sir.
everything
Thank
in
you.
the single lecture is not possible. I try to divide all the problems in the small part so that the topic which I choose must be complete very clearly. Everything can be discussed easily. Okay. So today in this single example, we compare Euler as well as modified and analytical, all the three, and also see
Sure, sir. Sure.
the one example. I will not expand about the example, but the second example just I wrote at its place, and I wanted to explain, but due to lack of time, I was not able to present this example. See this one. It's also very interesting example. I will provide the code of the same. Yes, see at this place. Okay, this is the differential equation. Y dash is equal to minus 2y and the initial conditions, and we want to compute at this place. Okay, this is the same method, and at this place we have the analytical solution. Okay. And here we have very nice coding, but I will not explain every step. You will do or yourself. You can see the both are result improved and analytical solutions are same. Okay, so in the first example, we discuss only one method, and this second example, we have the two analytical and improved, and the third one, we have the three methods. Okay, so everything when we have clear, then the convergence and etc. All these are very small things, not big problem.
Thank you, sir. Actually, sir, your
Okay.
interesting talk makes us so desperate to know all the things very early. That's why.
Yeah, this will help you in the coming sessions. Every
Thank
yesterday I discussed Euler method in very detail. Okay, so the today's method based on yesterday's lecture. So I skip a little bit, but try to explain every statement so that this will help you. But when you will play all this code, this will help you to write program yourself. So you must play with this code. Once you are able to understand, then try to write yourself. Okay, and understand, do the experiment on every statement. When you will do in this way, you need to operate operations on these script files. Operations means break every statement and see the result. This will increase your understanding, computing thinking, logical thinking, critical thinking, and all these build your skill to write the program. Everything is important. And some of you, I think, skip the last lecture, control statements. These are also very, very important. Okay, so I think the session is very useful, and tomorrow we will discuss some more uh, problem, and I hope that this will help you. If you have any more question,